I like that.
All right. So it's been so long since we have been in this class.
Yes.
Huh? Yeah, go right ahead. It's been so long since we've been in this class, even I had to go back and watch the latest video that I sent to y'all to figure out where we were.
Okay.
I know, right? It's been a hot minute. So, let's crack and whack at it, y'all. Let's get it. So, I left you with a question.
You did?
Yeah, I did.
What? It's 2 plus. Wow. That's not a lie.
Why
Wow.
do we salt the roads? Oh yeah, why we salt the roads?
I forgot.
Hey, I wrote that down.
Yes, but why? Why do we do that? Okay, so this is...
It raises it.
Salt.
It's not going to lower the freezing point, it's going to freeze it sooner.
Lowers the temperature it takes, or no, like, yeah,
Raises
lowers the
it?
temperature it takes to freeze.
It raises it.
No,
No,
it
it
lowers it.
lowers.
If you raised it, it would freeze more. It
Yeah.
lowers
Water
it,
is
so
polar,
that's
no.
easier.
Lowers the freezing point, raises boiling point. Don't mix the two.
Yeah.
Water and salt is polar.
If it was raising
Yeah.
freezing point, then it would just
Bond.
be worse.
Yeah.
If it lowers freezing point, then it's
Okay,
less.
so this is a point, like this is to show you what science is useful for in real life. So you got a problem. You got a road.
Alright? Give me a break.
Yeah, might as well.
Nice road.
Thanks.
It's better than the ones we've had.
Yep. We just got holes.
That's orange. They're supposed to be yellow.
I don't have a yellow marker.
Yellow wouldn't drop there.
Oh, potholes.
Not the black ice.
Wait,
What is
let's
that?
go with what's in Oceania.
Red light. You draw some like random gravel.
Is that a ramp?
There you go.
Oh, sweep the void.
Big old orange. Down in every time you go through. Don't forget the red light.
I love my state road employees.
There's no way I'm getting a red light on that. I'm not that artistic, alright?
Cracks.
Alright, so we got a road. So we get to the roads, we get this problem.
There's
Do we
too
have to
many
draw
holes
that
in the
road
road?
exactly?
No, you don't have to drop a road.
There's another pot sink.
Water the other road out.
It's like right.
Ah, it's raining.
It's raining.
Oh no.
Gravel everywhere.
There's no gravel.
There's no gravel.
Someone hit a blue
There is
jay.
gravel.
He's bad.
This, ladies and gentlemen, is what we call
Snow.
snow. Public Enemy 101, Wyoming County Schools having school. What is snow?
Frozen water.
It's real cold.
From the sky. Frozen rain. Frozen precipitation.
What is frozen water?
Ice.
Ice.
Ice, ice, baby.
Sorry. Alright, what is ice?
Cold
A
water.
chemical molecule.
Oh.
H2O.
H2O.
Water.
This is just
Water.
water.
Crooked water.
Frozen.
So it all boils down
No, it freezes up.
to that it's water.
Yes.
So we have water, which is snow, which hits the road, makes ice, makes for dangerous driving conditions. Now,
The fun of it.
remember water. I know it's been a while.
I've never heard this water thing.
Heard it crooked.
I've only ever heard
There's water. What type of bond
polar.
is here? Polar covalent. Polar
Yeah.
covalent. Yeah.
Okay, wasn't there snow?
Oh, no, I didn't know.
So the polar covalent,
Yeah.
polar means that it has what?
It bullies.
There's bully.
2 non-metals. No.
Okay, that's covalent, but
That's covalent.
that is polar. What is that saying about the atoms in there?
It attracts. It's non-polar.
They
It
should.
I
attracts
don't
polar.
understand what's going
Attracts
on
polar.
at all.
It has.
We are answering why we saw roads in winter.
I forgot.
Okay.
This is a problem.
What's going on over here?
Here,
Yeah.
this is
Oh.
water.
I remember.
Okay.
What's special about oxygen? What's special about hydrogen in this bond?
I remember. I don't remember why I remember, but it's like it's got that number. It's like 1.4 or 1.5 or something, and it's.
It's
Okay.
the
Powerful.
electronegativity.
What do the numbers have to do with it?
The numbers, Mason.
What do they got?
Oh,
That's going
delta.
back.
The wait, what?
Partial negative, partial positive.
Partial negative, partial positive. Dipole moments.
Oh, the numbers, Mason.
So, you got partial positive, partial negative.
We do a little squiggly thing too, don't we? Is that like, or is it just like normal?
Yeah, you do this squiggly thing. That's a Greek letter.
What is that Greek
Okay, I
letter?
have no idea what's going on here.
Yeah.
Looks like an S to me.
That's an
Alright, so you got the partial positive, partial negatives. Now, remind yourself, what is a common salt?
Sodium.
Sodium chloride.
Chloride. But what's sodium?
Partial
Partial.
negative.
Oh,
Positive.
there's no partial to it.
Oh, it's a
I was just
positive.
guessing. I'll keep it a buck with you.
Not a partial. Sodium is in the first column, which means it's easier for it to lose one electron and gain
What
7.
is partial doohickey you're talking about? I'm lost.
Yeah, how you determine that? I don't think I was here that day.
I've been out for 2 weeks.
This is all on this bond. So you look at it, you take the difference in electronegativity between the two. So if you look at the electronegativity of oxygen, electronegativity of oxygen, look on periodic table, you see it's 3.5. Subtract from it the electronegativity of hydrogen,
2.1.
2.1.
It is a delta. I was
So
right.
it's polar.
So when you look, that's 1.4. That falls in the range of what a polar covalent bond would be. Therefore, these are polar, which means polar.
What's the range
They have a
of a
partial
polar
positive, partial
covalent?
negative ends.
How you determine which
What's
one's
that
negative,
range?
which one's positive? Just which one's bigger is.
Which one's bigger is the negative. Why? Because it has a greater pull on the electron.
I'm so lost.
And what's the 3.5 and 2.1? I forgot.
Electric.
Electronegativity.
Where are you getting numbers?
Off the periodic table. Electronegativity. Bottom right.
Somebody invented numbers a long time ago.
No, you know
And we
that.
just believe them. We've been dealing with them ever since.
Okay, okay.
Boom.
Where there is language, there will be numbers. I'm
It's
just
not
saying.
periodic table.
That's not in there.
What?
But still, you have to go on this.
What about chloride?
They're spoken. It's technically language.
It is,
I forget what it is. Negative.
Negative charge.
How do y'all know this?
Why is that?
I don't know.
Because this is from ionic bonds, which we covered forever and a day ago. That is a cation. That is an anion. The sodium gives up an electron to the chlorine.
yeah.
The chlorine
Yeah.
receives an electron from the sodium.
Yeah, I never computed
Whenever that
this.
happens, they both get a full octet, but now they are bonded together because of the electrostatic interaction between the cation and the anion. Now, here comes the thing.
Okay.
Why is the salt working? Why do we put it on the roads? You already know that it lowers the freezing point.
Yeah.
But why?
It says nah.
Because water and salt are polar.
Just they bond
Or-
together.
What do opposites do?
Attract.
Right.
So guess what this partial positive and this negative do?
Attract.
They're attracted. We think it's partial negative and it's positive though.
Attract.
Yeah, but
Attract. So what happens is when the salt gets on the road,
Makes them
the
shake.
water gets there, it's attracted to one another, and once it's attracted, what is water very well known for? The intermolecular force of what? It's throughout the body.
Shaking.
It's the reason that the DNA is in the double helix.
It has bonds, hydrogen bonds.
Hydrogen bonds.
Oh my god.
So, what this does is the salt pulls on the those partial positives, partial negatives. As soon as it does that, it breaks away the ability for the hydrogen bond to take place, which therefore lowers the freezing point. Since the freezing point is lowered, we no longer have ice. We have a nice pothole road to drive on.
And now they're full of water,
Yep.
so you can hit
I
people walking
understood
on
none
the
of
streets with a nice splash.
Okay.
Refreshing mud hole.
Let's go through this again. Okay?
Blue Jay.
Y'all listening?
Yes.
Mm-hmm.
Snow. Snow bad. Snow on road, real bad.
Snow good, snow on
Black
road bad.
snow.
Okay? Snow is water.
So water bad.
Don't give water to anyone.
You're saying to not be hydrated.
By the
That's right,
transitive
drink Mountain
properties,
Dew.
stay hydrated.
No, that's too much sugar.
So
You
snow,
Yeah.
it's just frozen water, but it's water. It doesn't change. It's just in a different state. But it causes for bad road conditions.
That water should
Yeah.
have Oklahoma.
So what's a solution we can do? We need to break off the ability for these water molecules to form these hydrogen bonds. Easiest way to do that?
3-hour delay.
No.
I appreciate that, Jim.
Easiest way to do it is use the chemistry that's there, that partial positive, partial negatives that stack in there. Partial positive, partial negatives. If I put a true positive, true negative in there, it's going to pull on those partial positives, partial negatives, and that's going to be what's attracting it. Since it's attracted to that, it breaks off those hydrogen bonds, lowering the freezing point, which means you no longer have ice on the roads.
Yeah.
I'm still getting looks.
I'm gonna be honest, I
I
just
just
don't
blame it
put
with
enough.
way too many science words. Polar and covalent. Gotta break it down. Break.
I love coming back after a second break.
I'll be honest, I didn't write any of that down about the polar covalent because I was like, I'm not gonna be here. And I'm still
Like
here.
everything since
Yeah,
I
John.
started on is just.
Guys, like John's still
He
here.
refuses to leave. They're trying to prime
I've
away.
barely been here since January
but I
4th.
can't.
That's the last day I was here.
I had COVID.
Like
I
everything
did too.
since Christmas break.
Okay,
I missed for a number. I can't believe it.
that's the whole thing. The whole reason that we're using this is to pull on those water molecules, break those hydrogen bonds, so that there's no longer ice.
So why does it?
We use polar bonds. We use polar bonds against themselves.
Why
Why
are
are they
hydrogen bonds the
breaking?
difference maker?
Do what?
What makes hydrogen bonds the difference maker though? Like
Because what happens is water forms hydrogen bonds. So if we can break those bonds out, then it changes the melting and freezing points.
But why?
Yeah.
Because it's an attractive force.
Because chemistry.
Huh? And why do they break? What's
Because they're
like?
pulling it apart.
Yeah, they're attracted to other things. They're no longer attracted to
So
each
water's
other.
just that weak that salt is like, hey, I'm gonna beat you up.
No, it's water really likes salt that much.
Oh, so salt's getting beat up.
Yeah, the salt don't care. The salt's kind of like chilling in a crystalline lattice. It's like, yo, we're cool over here. And the water comes in and it's like, yo, what are you doing?
We forced the salt to be there.
True. We put it
It's
there.
non-consensual. That's terrible.
Any
Goes back to
questions?
salt
Just
water.
to get to school.
Yeah, we should just not
Salt
do that.
lives matter.
Question?
SLM.
So yeah, I never understood that. Whatever you said before, I never understood that. But that's when I left. That's when I got quarantined. Was we was in the middle of the cat-ons and the whatever.
Passions.
Yeah.
Anyways.
So, I have a question. How many of you have watched YouTube videos?
You have.
Thank God we got one.
I tried.
Oh yeah, I forgot those exist.
Mr.
I
Austin,
still don't
YouTubers?
understand.
You know what happens when I watch a
Fan will not
YouTube
permit me. Watch this second.
Yeah.
video.
Y'all need to break yourself out of wherever you're chilling. Like if you're trying to watch it where you sleep or relax.
It
it's not
doesn't
gonna
matter.
work.
I
Because
just.
if I watch it anytime I
Hey!
hear them, it just
Mr. Hall has something else to bring into your attention. So we have talked a lot about bonds. And I want to keep talking in on these bonds, but I want to talk about the strength of a bond.
The real bond is the friendship we made along the way.
So I want to talk about bond strength, and I want to talk about which one of these, when you're looking at them, really are the strongest.
Do they have muscle?
So, this first one's got muscles on his eyeballs.
On his eyeball?
First one, you'll typically look, because I haven't gave you the characteristics yet, but I will. But to break it down and look at you and show you a good indicator behind the strength of a bond is its melting and boiling points. If they have really high melting and boiling points, then you know it's a really strong bond. That's very characteristics of our first type of bond.
Metals.
Ionic.
Which is,
That's made up of a metal, right? It has a metal now.
That's a metal in it.
yes.
Ionic bonds are a perfect example. Think about things that are common to you that you know is an ionic bond. Salt. You know we have Bunsen burners. Those Bunsen burners are really stinking hot. Get really, really hot. I cannot, in this lab, with all the equipment I have, I cannot melt salt.
That's wild.
It's that strong.
Have you tried?
Yes.
So what if we made a crucible?
I have those.
And that still won't melt salt?
No.
Then what would melt salt? What do we gotta
I
get?
gotta get a higher temperature.
So we gotta throw lava on it or something? Or
If you want to go get it.
It's like a sauce slab.
There's a little bit of
How high
every
would
class
you
in here.
reach with the stuff that you have?
I don't know, I never tested it, but I know the melting point, I want to say the melting point of salt is it's over 1,000 degrees Fahrenheit.
Did we
What's
throw
the, what's the
enough?
highest that you've went?
What if we use?
I don't know, I've never tested it. I've went high enough that
This is what I was.
let's just say, I've seen some cherry red metal.
Yeah.
Some cherry red
We
crystal.
need some cherry red salt, that's the issue.
Number 2,
Can I eat it?
when you're talking strength of bonds,
Covalent.
are our covalents. Now the covalents, don't get me wrong, they are strong, but they are not as strong as the ionics. When you look at the covalent bonds, they're there, they have strength. It's hard to break them apart per se. But look at some common everyday things that you know are covalent bonds. Water. Water is a liquid, it's not a solid. I can go home, make some pasta, and I'm going to boil some water. If I boil water and I'm putting energy into it, we're breaking apart hydrogen bonds within it. It's a good example for you. When you break it away, they're no longer attracted to each other, you get steam, and that's just gas.
Yes.
Like the state of gas, not like, gas like, propane or,
Gasoline.
you accidentally tubed it or something.
Thank you. Really bad.
So that's what you're looking at there when you look at bond strength. Because when you see these things, you see other ideas that can go along with it. So focusing really in on like covalence. So we looked at double, triple, double, and single bond. And you got some things that's nice to know. Now these are pretty much common sense, not that rough or hard. Don't make it harder than what it needs to be. Don't make this harder than what it needs to be. Okay? First thing I want to talk about is your bond length.
I bet the longer the bond, the more fragile.
Yes, but that's not the direction I'm going per se.
But I'm still right.
So, the bond length is that average distance between two atoms bonded together when their energy is the lowest. Remember what this is when we're talking about energy. At this point, we're talking potential energy. And potential energy is all about energy being stored. So it's like all of you. You know, the second semester's getting ready to start, and you all have the potential to get an A. But we got to take the potential and turn it into kinetic action, work. Which brings me to talk to you about not only the bond length, but I want to talk to you about bond energy.
Oh.
Yes. Bond energy is one of my favorites. Typically, nothing against the ladies in the room, this is a guy's typical favorite. It's the energy
Of monk.
needed to break the bond. And a very good example of us putting in a little bit of energy, breaking some bombs,
Fire.
or boom boom.
Explosion.
Have you ever seen the videos where they like take the ice and they drop it? It explodes.
It was so fascinating. Like I watched one, like a guy had like a big piece of it,
Or like a,
and he
was it
goes
like
over
a
top
big
of like a
piece?
brick, yeah, over top of like a bridge, and drops it down on concrete, and you just watch it. You're like, I'm like,
That's pretty cool. I always get the ones where it cuts off and the guy asked me to check myself for cancer.
I've not got that.
I get those a lot.
I do laugh because Mary looks at me like, and she's like, what's so, like, why are you all about that video? I'm like, it's just, it's so satisfying. Oh, and it clicked on me one day. I'm like, you know how you are with your refill videos and how you love watching those? Yeah, that's how I am with watching guys break glass and ice. It's just fascinating.
Or push big rocks in it.
Hey, sticking with this idea. Sorry, I'm erasing the road. Bye-bye road.
It's okay, we need a new one.
Okay, we now. I want to ask you this question and look at this in terms of our bones. I'll find it so I don't mess up. I don't know, like mess up.
You were messed up.
So let's focus in on bond length first. So whenever we look at our bond length, we're going to look at the longest, medium, and shortest. Now, let some common sense come out today. Let it hit you. Let you know about it. Okay? Don't think too hard. We're talking in terms of our single, double, and triple bonds. Between all of those, which one do you think is the longest?
Triple.
Nice try.
Single.
Just single.
Oh.
Single, yeah.
What do you think is the shortest?
Triple.
Triple.
Definitely the double.
What?
What do you think is in the middle?
Double.
Double.
Double's pretty mid.
Where y'all getting this?
From my head.
Guessing?
What's this single, double, triple?
You don't know what a single, double, or triple bond is?
That's when you get like a baconator
She
from
hasn't been here
Wendy's.
for a long time.
I haven't been here for
Or a
this
Dave's
for-
burger.
Hey.
Oh,
Alright. So, this is a way to look at it. If you have something pulling on you, if one thing's pulling on you, it's easier to keep more distance. But if two things are pulling on you, it's harder to keep a distance. If you got three things pulling on you, well, It's really hard to
It's
keep
like
the
when you
distance.
catch a big fish.
The more things you got there connecting you, the more it's pulling you in. I like that. That's a
Like
good
that scene
analogy.
in Finding Nemo, where all the fish swim down,
Yeah,
tip the boat over,
yeah.
and kill a bunch of humans. I love when the second I feel it.
I love mashed
It's
potatoes.
like, you're the one that does all the YouTube videos that ruins Disney movies, right?
No.
I love when I see SpongeBob music.
So that's the way to look at it. It's a single. So the single kind of has a full. It's there, but there's a double. You're closer. Triple, you're the closest. Yeah. Don't overthink.
I'm thinking.
I want to talk about
Your life, your car warranty.
Car's
Same
extended
thing
warranty.
about your car's extended warranty.
on the energy. We got the strongest, medium, and the weakest. Or some people, the weakest.
The weakest.
All right, think about this for a moment, okay? I give you a moment.
The
Strong
triple bond is probably the strongest.
Have to be.
Yeah. the
Okay, so I gave you a moment.
Gotta be.
Got it.
What do you think is the strongest?
Triple.
Triple. Why?
Because
Because
there's more of them.
three.
It's also shorter.
There's three. There's more of them.
Yeah.
Also shorter. The
What do you think's in the middle?
Double.
Oh, look at y'all. I
Double's still pretty mid, bro.
And single.
You know, weakest?
I don't know.
The single.
Oh man. Is Eureka an English word, or did we just glean it from someone else?
It's probably like an old English word.
I don't care.
I'm gonna find out.
Hey, we don't worry about English in here. We just got it.
I don't
So this is all about the strength in those bonds. So whenever you look at them, you can know your bond lengths and your bond energy. So if you got something with a triple bond in it, it's going to take a lot more energy to break that
I
bond.
tried.
But it's also short.
It's Greek.
How's everybody feel?
I'm doing good.
Pretty good.
Very nice. Okay. Mr. Hall has held off on something, and he cannot hold off any longer.
Oh no.
Some things in our lives,
Are you ready for nomenclature out?
Mold.
Oh, no.
sometimes in our lives, we need to just ask ourselves questions. And I don't know about you, but I spend forever sometimes with questions, and I wonder why things are how they are. And I always find the curiosity rising within me that I want to know what's happening. How is it possible? Perfect example is this thing that none of you can live without.
Internet. Phone.
A phone.
I wasn't looking. I just.
Yeah. Look at this. Exactly my point.
Eureka!
Eureka.
We found Eureka. We found the definition of Eureka. Eureka.
It was very important.
Anyway,
It's very important.
your phone.
Yeah.
You can't
It's
tell
a
me
beautiful
not.
thing, right? You can't live without it, right? I mean, literally. We've become a society that if we're going to go poop, we got to go watch our TikToks while we're doing it, right?
I can't just sit there.
Don't read the
Listen, the funny thing of it is, all y'all laughing, and I know what y'all doing, okay? Y'all like dad your eyes and wouldn't look at me. Bravo to John that he'll admit to it.
I just stare at my shower curtain.
Well, it's worse when you forget your phone. You have to like read the
What'd you say?
Read from the conditioner.
Yeah. That's
How is it that we can have things like phones?
I'm like, hmm.
metal.
The fact that, oh, my phone's about to die, I plug it in and I get a charge, we get a battery.
Energy.
How's all this working?
Bonds.
How can we have the building that we have? How can we have the life that we have?
I don't know.
How is it that so many things are happening? It all revolves around this.
Why do we why do we get born just to die?
Oh,
You know something I can't comprehend.
question in life of crazy.
Why?
Technology
What's the
and
point?
pictures Like how
It's
is
just
Why don't we
so,
acknowledge that the
like,
CIA has
Like, I don't
really
get it.
confirmed that alien
Like
thing?
how is it so
And the Pentagon,
perfectly
Because
like
it's obvious that
fixed
the
on your little
universe is
tiny
expanding.
phones?
There's
Like
obviously something
and
is
just
somehow
clicked
growing.
it and boom, there it is.
But we live in a void of endless
I
nothingness.
I know
How
some
that
bunch of little
equals nothing
pixels,
is
but like,
growing.
that's crazy.
That makes no sense.
Yeah.
Something else.
Anyway,
She's like losing her
What's up?
mind for a big
So our teacher has told me something
the answer for you girls,
I'm spazzing.
Make me
I've
think
had a
about
few.
it.
without metallic bonds, this will not be possible. Without metallic bonds, we cannot have our phones. Without metallic bonds, we cannot have our light that we have right now.
Would we die without metallic bonds?
No, we wouldn't die, we would live, but
What about the iron in our blood?
okay, that's different. That's in hemoglobin, myoglobin, and the iron's there, and the oxygen comes in and it bonds to it.
So does that mean
You
we
need
still
it.
die?
That's
Or we-
different. Let me
It's
explain to you what a
common.
metallic bond is, and then we'll continue
It's
this
metal.
conversation.
Okay.
So metallic bonds are formed from a sneaky little group. There was a group that once Mr. Hall told you, don't worry about them. They're freaky and weird and do weird stuff. We don't care about them. You remember what they are called? What is also called?
Transitional metal.
The transition metals.
I've heard the word.
So, what do you think makes metallic bonds?
The transcontinental mail.
Transitional metals or metals. What's going to form a metallic bond? It's in the name, metal.
Yeah.
So here we are. We got our transition metals. And this is where you ever had that group that is like big brain moment? You had big brain thought, big brain moment, yeah? You're like, wow. I charge my phone before I poop. I can watch as much TikToks as I want. Yo, big brain move, right? Bigger brain move is someone put an electrical outlet in there and you're like, hey, you thought that's for your hair dryer. No, my phone's about to die.
I don't bring my charger with me to the bathroom. That's where I put the water. That's why you got chargers everywhere.
I have one in my living room by my couch and one by my bed. That's all I need. Oh, I got one in my backpack too. Carry in my bag. So metallic bonds, they got the big brain idea. I looked at you and I told you transition metals are weird. We don't look at them and try to figure out the valence electrons or nothing. And this is why. Transition metals had big brain idea, big brain thought. Big brain. Ready for this? Metallic bonds. The journey begins.
Journey to the lost
There's
island.
enough nerves. It can itch.
Forms from metal atoms do not freak out on me with this word that I'm about to say.
Anti-disestablishment theory.
Close, but no.
Supercalifragilisticexpialidocious.
No, definitely not.
Supercalifragilisticexpialidocious.
That's what it sounds
She
like.
just said that.
Oh.
Yes, I did.
You are insignificant in my presence.
Delocalized.
Also mine.
What's
Delocalized?
Deleted. Delegates.
You're not from around here, are you?
Delocalized.
Thanks.
They formed from metal atoms, delocalized. Delocalizing it would be better. Yeah, the way we're writing this one. Electrons to obtain full octet. Now this is what I'm talking about. Big brain move here. The transition metals sat there and they had a meeting. They came together and they met and they said, you know, they're all being dumb. Why in the world do you gotta give an electron, receive an
Well, we there,
electron?
girls, good luck tonight. They will be playing a home game against Midland Trail. We we would like all of our renegades to come out and support them tonight, and the theme will be tie-dye. Also, a reminder that everyone needs to bring your Chromebooks tomorrow because we'll be doing a device check. So please make sure you bring those, charge them up tonight,
In
bring them
person
to you
and
tomorrow.
period.
I need to see Whitney Morgan, Dustin Chambers, Allison Clay, and Ariel Lusk, please.
Okay.
Big trouble.
So this is where they look and say they're being dumb. They try and get a full octet, you know, because everybody wants to be like what?
The
Noble gases. They all want to be like noble gases, so they work through it and do this. Whatever it takes to get there. The transition metals had the big brain move. Said, let's just delocalize the electrons and get it there. Now, I know what you're thinking. Mr. Hall, that is not how we define things in your chemistry class. We still don't know what you're talking about. Let me explain. Let me explain.
Okay.
The metal
I thought that was your mouth just.
The metal meets. You're driving me nuts. Stop it. And has big brain idea. Yep, just a big guy.
Big guy. I tried a gun yesterday.
They take. Are you ready for this? It's this simple. They just look and they say, we're just going to take bikini bottom, electrons,
And move it somewhere.
and move it somewhere else. Exactly. They take the electrons and move them somewhere else.
You ever get the lives on your TikTok of somebody just streaming live SpongeBob? I do.
No, I get ones where they throw bones
Really
into a bowl, and they're like, oh,
I know what you all are thinking at this moment right now. Well, where's somewhere else? That seems pretty important. It is pretty important. The somewhere else is they don't care.
Wow.
You know what I'm saying?
It sounds like politicians.
You ever been there when people look and they're like, hey, you don't gotta go home, but you can't stay here. Bye.
Get out of here.
That's kind of one of those moments.
The Indian Removal Act.
Oh.
Go
Okay. Wow!
Western.
Man!
I'm indigenous, I can say this.
Oh my God.
You better get on out there.
Oh,
We won
So
this.
here's the thing. Here's what makes it so special.
I'm Lakota Sioux.
Whenever they do this, they build something very, very special for us. Are you ready?
yes. They go to barn.
Very special. This is the centerpiece. This is the crescendo, if you'll do,
Of the map.
for the idea of the metallic bond. This is what it all boils down to.
Nothing.
Sea of electrons.
See of truth.
Sea of thieves.
Jeez of truth. The sea of electrons. Oh, I love that thing.
I hate the TikTok.
So sea of electron. Electrons gonna go somewhere, right?
They go out.
So the sea of electrons are the electrons that were moved somewhere else.
Sometimes I think science is a lie and we're not real and it's just kind of like, plastic is just plastic, it's not that deep, bro.
Hey, this ain't psychology, alright? Let's stop. This is chemistry.
That would be philosophy.
This ain't psychology. Let's stop.
That would be
Again, if you're going to find a class here at Westside that's going to fill in and flow with philosophy, you're looking psychology.
Not really.
Your best not. Okay, I'll take it back. Yeah, your English class. Why was he wearing a blue shirt? Because he was depressed. He went on a date. He wasn't depressed when he picked out his clothes. He was excited. Who goes on a date depressed? Man,
Marcus Aurelius.
Why was their house flooded?
Or electrons that were moved somewhere else.
No,
They be free flowing.
disaster.
They're free. Oh, free falling. Flowing.
Oh,
Free flowing.
just hanging out.
Just hanging out.
That's the horse thief.
Got a chair in the world.
Just hanging out.
Exactly. So I have the perfect example for you.
So there's that one
Okay, are you all ready?
we're there.
Yeah,
Please, nobody have a moment of PTSD right now.
I'm probably.
PTSD.
What's he weird?
Does this ring any bells?
Oh God, I
It's all good, man.
I wasn't here on that day.
You lucky dog.
You got face.
We almost.
What is this made from?
Aluminum.
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 We're gonna zoom in and look at the aluminum.
Putting our books
I
up.
know, they're all getting up.
There's the bell ring at 2:49.
248 and it's 247.
I'll give it to you today. I'm gonna watch. Y'all sneaky little dog. It's been a while since I've been to this school. For a full normal day, you watch. I'm marking.
But it's
That's
probably
gonna
not
jump
like
up on me.
You're done.
Metallic bonds. And how special metallic bonds are. Metallic bonds did big brain move. Metallic bonds, they looked and they say, when the metals came together, they brought their atoms together and they said, hey, you got all these guys that are giving, receiving electrons. These bozos are sharing electrons. Man, they're making it hard.
Let's just genocide our electrons.
Why?
Sword. I don't know where how this did here.
Where in the world do they come up with these dumb ideas? Make it simplistic and easy. They look at these electrons and they say, hey, we don't need y'all. We don't care where you go. You just can't stay here. So get out of the atom. And they kick them out. As soon as they kick them out, then what we end up with is this beautiful sea of electrons. And this is where we left off.
Can you
Off
swim
of
in
the-
them?
What?
Can you swim in them?
I wouldn't recommend it.
Why?
The water's full of water.
Are they electric? Can you get shocked and die?
Can
Yeah.
I do the cha-cha slide?
No.
So, these sea of electrons are from the electrons that were moved somewhere else. They were kicked out. And they'd just be free-flowing and hanging around. So we were talking yesterday, and I pulled out a nice little example.
Can I inhale an electron? Just like,
In technicality, you are.
oh, let's go.
So, our aluminum foil. So, we're going to zoom in and look at what is happening with the aluminum foil. So let me put some aluminum up here.
Yep.
Get some aluminum atoms.
Whoa.
There's my aluminum atoms. And this is where we're going to pick up and really take off today.
Where do these atoms come from? Do they just like,
They disappeared.
it's like, hey, what up?
They went poof.
That's crazy.
So,
That's a crazy one.
aluminum, for example. Since we're using aluminum. I know you got this. I believe in you. Use the information that is provided for you and to you.
Where's aluminum?
How many protons does aluminum have?
I bet.
I don't know where aluminum is. Let me find it.
There. No. No. Wait. I forgot.
How many?
I used to know how to do this, but
I did too.
Yeah.
What is it?
13.
Why 13?
That's
Is
the
that to the
atomic
atomic
number.
number?
The atomic number is 13. Hey, you remember that thing I just said like 2 minutes ago? Everything in the class is starting to merge together? Yeah, that atomic number thing, we talked about that a long, long time ago. Number of protons in the atom. So anyway, we got 13 protons.
That's how many neutrons it has too. That
No, not a guarantee.
not always, unless it's like a isotope, right? How many different isotopes? But it usually has 13. Am I tripping? I'm tripping.
Or
I think you're mixing two up. We're going to not worry about the neutron.
Okay.
Said too many words, Andrew.
Because what's the neutron deal with?
Mass.
Beautiful job.
Yeah. I'm smart.
We're going to deal with the
On
electron.
occasion.
Now question, and please don't make me sit back in my chair again. I hate sitting in my chair. Darn, keep it straight.
Sit in your chair. Look comfy.
How many electrons does aluminum have?
13.
How do you know it's 13?
It's not, it's equal.
Atomic number off periodic table, elements straight off periodic table have the same number of electrons as they do protons. Now here's the thing.
Man, bam, thank you.
How many valence electrons does aluminum
3.
have?
3.
How do you know it's 3?
13th column.
It's in the
Yeah.
13th column.
I've read for that one.
So, aluminum has 3 too many. Guess what aluminum does?
Throws them
Throws them
away.
out.
Rid of them.
It kicks them out. Salt
No, it has 10.
Well, the street.
takes away the 3, leaves you with 10. So every one of these aluminums have kicked out 3 electrons. Just take a moment.
You just put 3 around all of them.
Yeah, that's it. But I gotta make them big so you see them.
That's what I got to see you bring your glasses for. That's so I can keep on.
Dim-a-dum.
So every one of them kicks out 3 electrons. Now this is the interesting thing where it all becomes magical and why you have this beautiful design of metallic properties and we have this beautiful thing that works with metals called the sea of electrons. We're going to do some complex math here.
No.
Everybody prepare yourself for your complex math.
I bet it's 13 plus
You
10.
tell Miss Cole and Miss Albright we get some complex math today.
Oh, you bet I was on Friday.
Is it going to be like 3 times 6?
Hey, you still got
It's
that?
We got 13 protons, 13 positive charge.
You still got
Oh,
that?
minus 10, I bet.
Got what?
You still got that dirt?
And I got 10 negative charges. What's a positive 13 plus a negative 10?
3.
3.
Look at you.
Oh,
We're going to
Destroy
destroy
the
the
SAT.
Yeah.
I don't know, that math question was hard.
So now the aluminum has gotten rid of 3 negative charges, which means every one of these have now got a 3 plus charge. Which makes them what?
Positive.
Yes, and what do we call them?
Partial positive.
Nope, they're not partial, they're full on.
They're full on, but I'm going. I bet they're
An anion.
cation.
Anions are negative.
Cation.
Cation.
Oh, I thought you didn't like cats. I forgot.
I don't.
Oh, see, now you done trip me up.
No. How is Mr. Hall anion English?
Bad.
That's how I remember. Anyway.
What?
Okay. I'm bad. I'm bad in English. Andrew got it.
Anion, we just
He
obvious?
said, how am I?
So,
English.
we have this beautiful sea of electrons. What you're going to see is every property we have for metals come back to this beautiful design right here.
I bet it smells like high cup.
No.
Oh man.
Everything's better.
So this is what I want to do. I want to discuss the properties within the metals.
Stainless silver.
I'm really hoping to pull a swindle on you there.
Mr. Hall is flabbergasted at this.
Props. Metal props, metal properties, however you want to spell it, I don't care.
We're going to talk about the metal properties. The first one, you all will look. What in the
Chapter 2 bio.
world? Anyway, number
Hey,
one.
you don't need that.
Nitrogen usually has 3 covalent bonds, apparently.
That's because it has a triple bond.
Hey.
Exists in nature, bond to itself. It's the most stable bond on the planet. We discussed it.
We did indeed.
Chapter 2 biology.
And in a lesson in chemistry. I can't give you a chapter because we don't do a book. Anyway, so metal properties. So, I have a question for you guys.
Under the sea.
Wrong movie. Have you guys ever watched Moana?
Yes.
Yeah, I like Moana.
What can I say? You're welcome.
Wrong song.
Uh.
So y'all remember like the part in the movie when he's
He's
going
gonna
to get his
try.
hook?
Power.
The shiny crab.
Shiny.
So he's trying to get it and he finds himself and he's down there fighting this big, really huge crab.
Yeah.
Put all this metal on the back of him. Why'd he do that?
Because it's shiny.
Because it's shiny.
It's shiny.
Shiny.
Luster.
Like
So, the first property we're going to discuss. Now, I can't say shiny because that's not the scientific term. Okay?
I think you can.
shiny.
Is it luminous?
I think it's
The
luster.
first one is called luster.
Free.
I told you.
Luster, oh, I think I.
Is that guy from GTA 5?
Now, I know what you're saying. I know what you're going to say. Mr. Hall, that's not how we define things in this chemistry class, because not a lot of people gonna understand when you say, look, hey, yo, man, look at that. That's luster right there. Yeah. They're going to look at you like you an idiot.
He got the hops off me one time.
So,
Me and him robbed a bank.
He got me.
all luster is, it's like the crab. Not Mr. Krabs, but the crabs from Moana.
I think it's just pretty to say shiny.
Buy a high-end apartment. I bet that crab smells like garlic.
Hey, that's Lester.
Is it?
Yes, I did that on purpose because I did it in the first period to wake them up, and they still.
You spelled shiny wrong.
I did it in first period to wake them up, and I thought of y'all when I did it, and I still wouldn't do it again.
You spelled shiny wrong.
You didn't listen to him say it though.
That's shit.
That's how the crab says it's shiny. That's how
So the first one's all about luster, shiny. Now, here comes the cool thing. Did Mr. Hall tell you anything about getting this class things coming together? I want to make sure I mentioned that.
Like a bunch of related logs.
This is what happens with it.
Whoa.
What if instead of Lincoln logs, we had Washington logs?
The funny part of that was how quiet it was after you said it.
Yeah.
Still everybody's eyes on you.
I don't know.
Okay, so why is it the property, why is it so shiny? So remember,
Or Jefferson.
those
No.
delocalized
Oh, I remember them. That big scary word.
electrons
The deported electron.
you know,
And then ones
The
that ain't
ones-
supposed to be here anymore.
Or the deal
that
Don't have their
were kicked out.
They can't take our jobs.
green cards.
Need to get them electrons legally into this place.
So those delocalized electrons, those are the ones that are red up here, the ones the atoms have kicked out. Okay?
Oh man.
Those delocalized electrons, they, you're gonna like this. I hope you'll remember this.
Okay.
Absorb
Oh.
any frequency of light.
Why only one frequency?
shiny?
Frequencies, whatever.
Many frequency. He has many frequency, my friend.
Fine, finish the statement, boys.
Oh,
I didn't think so.
Thus.
No.
He would definitely wouldn't say thus,
Yeah, you're right.
even if it was correct.
Therefore.
Thus,
Henceforth. He said thus, John.
the electron go
Verb.
to
Oh.
an excited
Disco. Target.
state.
Uh-huh.
Thank you, Michigan. So much
Michigan is
there's
boring,
hope.
bro. Florida.
Florida.
Us.
Florida is an excited state.
Hence,
Not Arkansas.
California's condiment. Free weed.
they won't stay there.
Colorado.
You're right, California.
I don't know what they're talking about.
The
Stay
excited
there.
state.
They won't stay.
Hence,
They have to release the energy.
they won't stay. Thank you. So they
Is this what happened?
go to the ground state.
Whoa, not the ground.
And they explode.
Releasing
Hold on, man. You gonna have to start.
Photons, I bet. I bet it's photons.
Energy.
energy
Oh man.
in the form
Of
Of
photons.
song.
of light
Please.
flash photon.
I just want to hear you sing a song. God bless.
America.
And all its beauty.
No. This place
That was a
sucks.
lot of work. Just for.
Shiny.
I remember that in GTA 5.
Buster.
We didn't talk about the main frequency tonight.
We talked about the many ways to blow up in a bank.
This is the first property you're going to see when it comes to metals.
You gotta paint.
That's why aluminum foil is shiny.
It's lustrous.
Gates.
Isn't there
Luster.
What is it?
there's how many of those are there? Like how many?
Properties?
Yeah.
7.
We're going to do 3 properties.
23.
And then we're going to break it down into another segment that I like to talk about.
72. Probably.
But they're ready.
Is
691.
one like bendability, like how bendable the metal is?
It just depends on how much the middle
Durability.
stretches.
Yeah, durability.
I'm so proud of you.
Is it hardness? Is
I'm
hardness
going
one
to
of
give you an
them?
air high five. I'm proud of you.
Is it, Mr. Hall, is hardness one of them? Most skills of hardness?
No. Number 2. I was scared this one would catch you off guard and frighten you and scare you to death.
I'm scared.
Malleability.
What?
Yeah. Oh. What's that?
Malleability.
I'm going to define it.
He's finding it.
How malleable is it?
How
Certain
malleable
metals
is it?
are very malleable.
Malleability.
Malleable.
Sorry.
Alabama.
Much better.
Yeah.
Compare it to another. I bet you missed.
Good
You want me to
shot.
make a shot?
So malleability, no. It's the ability.
Metals have abilities?
Yes.
We got superheroes?
Of
I say Lee Harvey.
the metal to be
I think Steve Harvey dies soon. Just saying.
flattened
I thought I did John Rose Booth.
into sheets.
Yeah. Like sheets of aluminum.
Exactly like sheets of aluminum.
That's like when you get the tin roofs.
Or
that
gold.
you put on, and they bend in your hands when you're moving them. And they're like,
Whoa.
you know what I'm talking about? I was in there one time in the rain, and I was holding it, the water was coming off of it, and hit me in the face, and I was just holding it while somebody was screwing it in. Just,
Oh yeah.
You can make it sound like thunder.
What about gold?
So here's the thing. Here's another thing you can see with it.
Mr. Hall, what about gold?
It's a thin, very thin sheet.
Yeah.
So here's what you can see with it to also help you with it. You guys ever watched? They got on to me in first period because I didn't use that proper term. You ever watch them forge a sword?
Yes.
Yeah.
Yeah.
So what do they do with it? They get it really, really hot, like red
And they-
cherry hot.
They get
If
more
the
than
flag
chicken.
is out.
Never Game of
And then they crack it some more.
So what do? They get it red cherry hot and they pull it out and they whack, hammer it. What's happening?
They're malleability-ating it.
They're using the property of malleability. Why? Because what happens is when the hammer hits it, it dents it and it pushes out. So it's thinning the metal out.
Make it sharper blade.
You want to get into forging with
It'll
me?
get it to where they can get a nice blade edge on it.
What's
It'll thin it out.
fire?
So the malleability is just that ability of the metal to be flattened into sheets. Now, why does that work?
You want to join us, Joe?
Because malleability.
I'll smack a hammer around.
Okay,
We're making swords.
Andrew,
Can I go?
we've had a great start to 2022 with you, but you're going back to 2021. Let's just pull back a
I've
little
been
bit.
gone for
never
a few
forget.
weeks, Mr. Aller.
Just pull back a little bit. Just
Remember the
chill.
one day we
Breathe.
thought John was leaving,
Relax.
and Andrew stepped up. Don't ever do it again.
So,
What I did?
malleability is the ability of the metal to be flattened into sheets.
Yeah, we thought-
This is the reason as to why. Remember, those delocalized
Oh man. Are we kicking them out when we smack the metal?
electrons
That'd be crazy.
that are just freely hanging around,
Free flowing, just hanging in.
they allow for the metal to move freely.
How does that make any sense whatsoever?
If I don't answer your question in 5 minutes, then ask. Okay.
But we've been in class for a while.
Smack
He's
him.
getting ready to write it
Smack 'em.
down.
Smack him.
Kick me in the head.
Can I do it? You start not look behind you.
They allow for the metal to move freely and flatten out. This is why, when you look, these electrons are just freely hanging out. So this is kind of like what it's looking at. Let's
So-
say,
If it's flattened out, they push up against it? Or would they just still be hanging out?
they're still hanging out.
Okay. They fill in the gap.
So here's the sheet of aluminum foil. And this is what we'll see happening whenever you're wanting to flatten it out. This isn't like an ionic bond. It isn't. This is chilling here, but as you push it, these electrons, they're not connected to anything in particular, so they'll just move out of the way. Whenever they're doing this, it allows the atoms to move out of the way as well. They'll just flow out of the way and move. That's why you can take a hammer and slam metal and it dents. Unlike if you took some salt and you put it on a table and you slammed it, what happens to the salt? It becomes a powder. Why? Because you can't line those ionic bonds up. If you line up a positive with a positive, it kicks it out. A negative with negative kicks it out. They repel each other. Which brings me to pull on you for a moment. These electrons were kicked out of the atom, right?
Yeah.
Yeah.
Why are they still here?
Just a suffer.
Because they're neat.
Why? Why stay? Why stay here?
I
Because
bet
they
it,
fill in the little gaps. maybe.
I have a theory.
Or could it be if you
Because they're
crumble
trying to
it
jump the border.
I have a
if you
theory.
reheat it?
That's
They
because
walk
there's
back
mass.
in. They
And so
walk
they
back
can't
in.
escape
Where else would
until
they
there's
go,
another
though?
mass
I
to
don't-
pull them away.
They add
I
them?
don't understand.
Well, I don't know what it is.
They go wherever they want.
That big thing is the Berlin Wall. And that.
They just like standing around the
What's in the
people.
air? Molecules,
Nazis
compounds. An electron could look and say, hey, you want to jump over here?
Or would they just bond with the aluminum foil?
They're not bonded to it. They're staying around. They're hanging around.
Maybe they want to reach something, they didn't want to go out there.
Or
Yeah.
if it's a crumble again, come back.
So it's not.
Come on, think about it. Think about it.
They're not around the
Really
mass.
hard right
Is
now.
that not it?
Did you see it? Yeah, I can see it.
Are the electrons? I got a positive and negative. Because those are electrons that are negative. And because those ones are positive now, they're staying.
My 2022 Andrew's back.
Let's go!
Okay. What is the aluminum? It's an ion. But what type of ion? Cation is a positive ion.
Okay, I got it.
What is an electron? If you're going to learn anything out of this chemistry class, you're going to know.
Subatomic particle.
You're going to know what an electron is. Negatively charged subatomic particle.
On job.
So, what do opposites do?
Attract.
They attract. Why are these electrons not running off
Because they're
somewhere?
negative.
They're attracted.
They're negative, and what are they sitting around?
Positive.
Positive charge.
They can't really
They're
go
going to hang out. Why? Why do they want to go anywhere else? They're
It's like-
attracted right here.
It's like you were being evicted and you still have to pay to rent on the place.
Crazy? I was crazy once.
They put me in a room full of rats. Right?
So here's what happens. Whenever we hit this, it'll push out. Why? What's the electrons attracted to? The atoms. What happens with atoms? They push out.
So they just move out of the way. Okay.
They just move. Everything here within the metal can just move. Why? The sea of electrons. They're just hanging out.
It's just
So,
They're just there.
Okay, so like it keeps them from. How's that? Keeps it from burning.
it doesn't keep them from anything.
It's kind of like this. So whenever we did the crystalline glass with the sodium chloride, you remember? Na plus, Cl minus, Cl minus, Na plus.
Yeah.
For example, okay, now we build it bigger, but I don't want to take all the time to build it out. Positive is trapped with the negatives. What happens if you take a hammer and you slam salt? This is what takes place.
it goes buoy.
These shift. So whenever they shift, what would be up here? This is a chlorine, so there's got to be a sodium.
Yeah.
This is a sodium, so there has to be a chlorine.
So they just switch up.
So it shifts, and it'll line up with a chlorine to chlorine.
So it wouldn't attract.
So it throw
It would
itself
just be
everywhere.
positive and positive and then negative and negative.
Yeah, but what happens? What do like charges do?
Will they throw each other out?
They repel, so
So they
this breaks.
So
This breaks off, and this breaks off. This is why you see the powder form.
You hear
Yeah.
table
It
salt,
breaks
that's how
apart.
It goes like everywhere.
Because you can't line those up together. That's why we can break things apart like that. Metals, why can't we?
Because they're not-
electrons.
The sea of electrons. There's all that negative stuff in here. There's the positive ions. But they have those electrons that are all hanging out together. So you hit it, they're moving out.
So they can't like hit the other positives to it.
No, because what's around it?
Oh, that makes
What can build barriers?
So they're cushions.
Oh, I can move glass.
Yeah.
I can
You can
heat it up
move
a
glass if
little.
you want to.
Let me get glass hot enough. I guarantee you.
Well, not the same color, but yeah.
Well, that's because you're putting energy into the
No,
sand.
they're close. This is just for scale and stuff like you guys can see it on the camera whenever you watch it later on.
You get it red hot and slam
Well,
it on the
no,
ground.
dear.
So that's how you build
When you
it.
get the sand hot and it becomes glass, that glass.
Now we're gonna talk about one of my favorite things in the world. This is my personal favorite property of metal.
Is that the one that makes it bendy?
Is it street?
That's how you build it.
Is it
Nah,
the?
I don't think.
Is it the? I forgot what it's called.
Bye-bye shiny is malleable.
Is this the one that?
Durability?
Is that
Yeah, the
heat?
strength of
Let's see
it.
some heat.
Strength.
No, is it the?
Let's see some heat testing.
resistance.
Oh, let's see some electricity.
I want you to heat
What's
treat.
this?
Conductivity.
What is it?
What's this?
What is it?
What's
Strong.
Number 3.
I don't remember the word, Mr.
Fire. Durability.
Duct
Ductability.
Duct tape.
Duct tape.
Duct tape.
I was entirely
Just like electricity.
I was so proud of Owen in the first period. Whenever I put ductility up there, he went quack. It's like a dad joke, yeah.
Okay.
I held that one back. But
Then whenever I said ductility, he said, man, I missed a good opportunity for a joke about 3 minutes later. And I was like, what? He's like, ductility over our heads.
We want to have a quacking contest. We're barking up
The air
tree.
ducts are above our
You're
heads.
quacking up the wrong tree now, but.
Ductility ductility is my personal favorite, and it's also your personal favorite. You know how I can tell you that? Without this, you could not have the life you have today.
What?
That would make me like it more.
If we did not have this problem. 2022, Andrew, not 2021, okay?
Yeah, you're talking this stuff now.
Now
you gotta go to the camera.
Oh no.
This is the ability
Oh.
It's purple.
of a metal.
That's it. Just
You know-
leave it
I
there.
have your attention for a few announcements.
Okay.
This is for seniors. The new Oceana High School Alumni Scholarship application
Senor.
is available in the scholarship file cabinet in the counseling office.
You know, some random
Completed
hobo came up to
applications
me
are
and
due
gave
to
that
Ms.
to me.
Stewart on or before February 21st. New scholarship applications for the Aaron Scott Memorial Scholarship, Wolf Scholarship, Little General Scholarship, and the UMWA Scholarship applications are also available in the counseling office.
I watched a
The
video on that
scholarship
film before.
bulletins are available on the round table in the counseling office. The Bridge Valley representative that was scheduled for earlier this month has been rescheduled for this Thursday, the 27th at 1 p.m. Your next FAFSA day is scheduled for Thursday, February 24th
I'm
from
so
9 to
sorry.
2. If you haven't already completed your FAFSA, seniors and at least one parent need
Sean
to attend
Payton
to get
stepping
your
away as the
FAFSA
head
completed.
coach of the
Thank you.
Saints. After 16, I'm not playing right there. It is from ESPN. I'm not messing with you.
Skipper told you that earlier.
Baseball conditioning this
I didn't
evening will
believe him.
end at 6 p.m.
Okay.
The ESPN just released it 30 minutes ago.
Hey, you're gonna be even worse now.
Levi?
Real shame there, buddy.
All right, anyway, so sorry.
That's
Hey,
not
by the way,
Levi's team.
I got a text from one of my former chemistry students yesterday, and he told me, he said, I'm so triggered right now. And I said, why? He sent me a picture of his chemistry class. You want to know what color marker his chemistry professor teaches in?
Purple.
I cracked a joke. I told him, I said, I would too, man, if I had the funds, but this guy ain't got that funds. There's a reason I
Is
use
purple expensive?
Well, you gotta buy it in like separately.
You have to buy
The office buys the black ones.
So you have to buy the colored ones.
I buy the colors. Now, if I wanted to, I could put in a request in the office and they would get them, but I ain't gonna do that. I
Give me
mean,
all the purple
You should do
markers,
it.
please.
I'll spend $30-40 on markers a year. That's the kind of love I have for y'all. Anyway, so ductility, the ability of a metal to be folded to a wire.
Yeah.
If we did not have this ability, we couldn't have the wires to run the electrical currents throughout our homes, throughout our schools, throughout our buildings, throughout our businesses. We wouldn't be able to charge the batteries within our phones. We wouldn't have batteries. We wouldn't be able to have electronic devices. We wouldn't be able to have technology. We wouldn't be able to sustain and have the life that we have without ductility.
I think we'd find a way.
Now, malleability is just as important. Now, luster, yeah, who cares about a crab singing about being shiny?
Me.
Hey, you got a new mask?
I'm sorry, man.
Are you okay?
You are a Saints fan, not a Sean Payton fan. Own up to it.
Sorry,
Own up
man.
to it.
So, how does this happen?
It'll suck even worse.
Remember,
It's gonna be even worse too.
sorry.
It's what it is.
Delocalized
Oh my goodness. Them things are gang.
electrons
Oh my goodness.
that are just freely hanging out.
Just be free from hanging out. I can't speak. Chicken ranch and bacon sandwich.
They allow
Jacob Hayner to the office.
forward the metal to be cleanly pulled
Is there a way to stop metal fatigue?
into a wire. Sure,
You don't want to get metal fatigue is? It's, you know, like when you bend a little wire enough and it'll just snap because like microscopic.
yeah, there is.
How do you stop that?
Don't bend it.
But like
Oh, that's
wires,
really
like
good.
what about
I mean-
like headphone wires or something? Like
I
what if you had a metal?
Don't bend it. So, you can also buy braided wires and cables instead. How this happens is right through here. Let's say I want this strand of aluminum wire.
Yeah, I got those too.
It just breaks
So we
off.
would pull right through here. Guess what would happen? If there's electrons here, they go to the right. These go to the left. It just freely moves.
Clean break.
Exactly. It's the same reason why you can take aluminum foil
Rip it.
and just easily pull it. What's happening?
It's ripping.
As I'm ripping it, it's pulling between these. I got stuff going to the right, I got stuff going to the left. They cleanly pull off
Are you that strong?
and will tear.
I
know. Yeah!
That's a metal, bro.
Two pieces.
So listen, tomorrow when you come in here, we will be talking about why they do that.
Yay.
One of my favorite segments to get to in chemistry.
Let me give you a little bit of.
Joy to the world. Besides that, if you have not made up your polyatomic ion quiz, you need to make that up. That is your final for the first semester.
Go, someone.
Also, along with that, you have to cast your votes tonight for your favorite soft drinks for the lab.
Red Bull.